All right, welcome back, everyone. Man, these sessions are just flying by. So much good content. Like I said, we have another great case study coming up, and this one I'm particularly excited about because it's talking about and using a lot of the technologies that I work on at VMware, Spring Cloud, and all the great stuff that falls under that umbrella. So without any further ado, I'll let Joris get started on this and tell us a little bit about microservices and the Dutch lotteries.
Hello and welcome everyone to this case study on winning the lottery with Spring. I've actually changed the subtitle a little bit to be a microservices case study since this became a breakout session of 25 minutes. So what I've tried to do is actually stuff as much information as I can in there without trying to confuse you all too much. My name is Joris Kuipers. I work as a CTO and hands-on architect for Trifork Amsterdam. Still do some occasional Spring trainings as well, because I actually used to work for Spring Source in the past, and well, as such, I'm still involved with some of that stuff. And today I want to cover some topics that, as my work as a hands-on architect, we came up with and that we encountered in a project that we have been doing for the Dutch lotteries. Actually, they don't like to be called the Dutch lotteries. They like to be called by their Dutch name, which is Nederlandse Loterij. What we're doing for them is for almost 4 years now, we've been building an integration platform for them, basically. And we've been doing this because they have been moving from a mostly single vendor solution to a best of breed multi-vendor landscape where there are a lot of different backend systems involved in the day-to-day operations of their lottery. And there's also a whole bunch of different front-end systems that need to be able to interact with and connect to all of those backend systems. This involves user-facing systems like websites and mobile apps, but also a lot of things that you may not immediately think about, like cash registers and terminals and that sort of thing. The idea behind this move that they made from going from single vendor to best of breed was that they would get more control and speedier way of doing development. But to actually get those benefits, they wanted to have a gateway-like solution in the middle to encapsulate a lot of the details on how you need to communicate with backends, right? Technical details, but also different APIs, different names and concepts used for what is actually within the domain of the lottery, the same thing. And also to provide some ways that, because we might have some centralized APIs, we could actually replace some of those backends without immediately breaking every client that is somehow involved with them. So that's what we set out to do, and that we've done successfully. This platform has been running in production for over 3 years now. And from a player point of view, we are serving more than 2 million users that are playing with some of the lottery games that the Nederlandse Loterij provides. We see big peaks every now and then because a lot of lottery stuff is not 24/7, right? There are draws at particular times. So the state lottery is actually one of their biggest games. Whenever that's happening and there is a draw, we see a lot of peak and usage there. We also see it with big soccer games because Toto sports betting is something that they provide. But you can imagine that there are also peaks in backend systems. For example, when everyone who has a subscription, so they automatically play, has been invoiced successfully, and now all of the tickets are being issued. So that's the sort of thing that we're involved with there. Now, as an architecture, we set up something that looks a little bit like this. We have public APIs, which we call experience APIs. This is the stuff that our clients interface with, right? And this is what we describe using open API specs and everything like that. Then those experience APIs typically talk to a process layer that does orchestration. It knows, in order to do this single thing, I actually need to talk to 2 different backend systems, and I need to do that in order, or maybe I can do it in parallel. Maybe I can do some stuff asynchronously. So that's all handled there. And we have some dedicated system APIs that are used to connect to backend systems. Not for every backend system do we, in fact, create a dedicated system service, because that would be a bit too heavyweight of a solution. But we do this for the big important backends, like the central system that performs the actual lottery operations, and like the player account management systems. They get their own adapter service, basically, that knows how to interact with those systems and translate stuff into our own domain language, basically. Now, in order to build these things, we are using Spring Boot, or actually Spring Cloud. We built these things into Docker containers that we are running on AWS. When we started off, that was running on AWS ECS, which is their proprietary Docker orchestrator. We are in the process of moving over to EKS, which is just a managed Kubernetes solution. For the purpose of this case study, that's not that important, so I'm not going to focus too much on that. We started this project at the end of 2017, and that's just around the time that the core Spring framework came out with the first support for doing reactive programming using Spring Webflow for web-based applications. And that was just a little bit too early for us to already jump on the bandwagon and say, yeah, this is what we're going to use to build our platform, even though it would have been a good fit from a technology point of view, right? Asynchronous and non-blocking AI is basically the stuff that is the bread and butter of building gateways and integration solutions. However, things like Spring Security, the whole Spring Cloud stack at the time really wasn't ready for that yet. So we are currently actually based on the traditional Spring MVC blocking model with Tomcat in there. We are one team actually building this. I'm leading this as an architect, and on different times we had around 5-6 people on the project. And for that reason, we've chosen to put all of these services, which is currently around 30 of them, plus a bunch of libraries, inside of a single Git repo with a single Gradle build that produces all of the actual Docker images that we end up deploying. Now, one of the benefits of doing this, because there are multiple actually, is that it's quite easy for us to build shared libraries that can be used by a variety of services inside of the same repo. We don't need something like an Artifactory or something else where we actually publish these libraries to, because they are simply part of the build that we're doing. So here on the right-hand side, you can see a little screenshot of Mighty, where under the libs folder, you can see a whole bunch of these libraries, right? So these are Java projects that do not actually produce a Docker image. They're just Java libraries. But then under player, for example, you can see that we have a player experience, we have a player process, we have a player system. And those are all Spring Boot services that we end up deploying in production. So for this talk, because as I mentioned, it's going to be a micro use case because we have 25 minutes only, I decided to focus on 3 things that I wanted to demo here that are things that I haven't really talked about in public yet much. So it's going to be new. But also that I think will teach you something that you can actually take back home and to your own project and start applying, because you get some nice new ideas. And the first thing I want to talk about is Spring Boot auto configuration for the people, by which I mean applying auto configuration in your own projects. The auto configuration itself is probably the most well-known feature of Spring Boot, right? It's the thing everyone knows about. Spring Boot just allows you to create this application, you add some dependencies on the class path. You're probably using the Spring Initializer for this. You start it up and boom, you have a running application. It's magic, right? This is actually something that some people will actually tell you, right? Oh, it's a black box and it's magic, so you shouldn't be doing that. Of course, those people don't know what they're saying, because actually Spring Boot auto configuration is really just conditional configuration classes, right? It's actually really easy model to understand as a Spring developer. It's basically configuration classes that are prepackaged with the framework and that provide you with some Spring beans that may or may not be initiated at startup based on certain conditions, like if something is available on the class path or if you have already defined something yourself. The way that this stuff works is basically all you do is in the library, you create a meta in Spring.factories file. And within that file, you can list one or more auto configuration classes that should automatically be applied by Spring Boot if this library ends up on the class path. And there are a lot of benefits actually on applying auto configuration yourself in your own projects, rather than just relying on the given auto configuration that Spring Boot or other frameworks provide. One of them that we found to be very beneficial in our project is encapsulation. Right? If I depend on a library, that library will typically expose some public API, which is the thing I want to use. In our case, it could be a client that knows how to talk to some external system, for example. But there's going to be a lot of other stuff in there as well that is internal to this library. I don't really want to know about it. Now, for Java itself, that simply means that you're going to have types in there that don't necessarily need to be public. But when you're using Spring, we don't just need types. We want to have Spring beans. We want to have managed objects. So someone also needs to know about what objects to create. And auto configuration is a really nice way to just let the library deal with the configuration concerns that it has purely by itself, and then allowing the client to just use the result of whatever that is. Also, because Spring Boot auto configuration is actually based on conditions, it becomes very easy to say, yeah, I want this bean, but not always in exactly the same way or not in every situation. So, for example, if I'm developing on my local laptop and I'm just starting up a service there, I may want to have some things that are different from when I'm actually running on AWS. And that is quite easy to do when you have auto configuration. Also, you can provide defaults that are very easy to override because you can have beans that are conditional on the existence of other beans. And this is especially nice because when you're using actual auto configuration for this rather than regular Spring configuration classes, there is a well-defined order here. Everyone that creates their own configuration classes in their own services will always define things first. And only when that has happened, the auto configuration will be evaluated and it can check based on these conditional things like, oh, do I actually need to do this? It also makes it just really easy for clients, right? Just putting something on my class path, I can put a README in the library says, yeah, this will actually expose an object of this type, and you can start using it. When that needs certain configuration, I can provide a configuration properties class in there as well. And again, I can just get discoverable configuration properties as a service, and everything will be nicely there in that single library. So I want to show two examples of this, how we apply this. The first one is that we have an auto configuration library that is used by pretty much every service that we have to configure the use of our HTTP clients and REST templates. So one thing that this thing does is it sets up an Apache component HTTP client because that's our HTTP library of choice. Now, out of the box, this thing has pretty poor defaults, especially for enterprise applications, right? It doesn't have timeouts configured. It doesn't really allow for a lot of parallel connections to the same backends. So this is all stuff that you really want to change. And since it has to be done for every service, this is something that we want to configure centrally. Also, we want to make it we want to make it easy to actually configure different values for these, right? We can have some sensible defaults, but they're not going to apply to everything. Also, once we have that Apache HTTP client, we actually want to make sure that our Spring REST templates are using that thing. And in addition to that, we also have a lot of stuff we want to configure for the REST template. For example, we can dynamically configure it to log requests and responses. Now, if you do that, if you want to log responses especially, you also have to make sure that these responses are actually buffered by Spring, because otherwise, if you read the response in an interceptor that does some logging, well, the actual regular application code can no longer read it. So you need this wrapper. I'm going to quickly show you, not as a comprehensive overview, but just that you get more of an impression of what this looks like. In our system, I've shown you a class like this. So what you see here is that we are in the library. We have the auto configuration here. And then we have an HTTP client properties, which is the configuration properties class for this thing. So here you can see that it responds to configuration that has a name that starts with http.client. It has defaults for things like timeouts, and there are setters and getters where this can actually be overridden by libraries or by clients of the library, I mean. What we see first thing here is that we're going to create an HTTP client. This is an Apache client based on a connection manager that we have configured. The connection manager is a separate bean here, and it's configured with a connection time to live. So this is one of those things that is like super important when you're doing integration. You need timeouts there. Then other things that we do here is we're going to make sure that, if we want to do some logging, we better actually wrap the request factory in a buffering client, HTTP request factory, unless that was already there. This requires some reflection magic, by the way, because Spring might already start to wrap stuff. So I'm not going to actually show you the ugly details, but you get the gist of it, hopefully. And another thing that we do is we actually remove some stuff as well. Spring by default actually creates two Jackson converters inside of a single REST template, which is really more of a mistake than something that I do on purpose. But that can actually have some adversary effects. I wrote a blog about this. You can check out on blog.trifork.com. But this thing will basically just remove the additional stuff that you really don't care for. And all of this simply ends up being applied to every service that uses this library. And some of our application developers don't even know about these defaults, right? This is pretty low-level stuff that you just want to do once and then get out of the way. So that's an example of something that we apply on many different services. And because we also have this configuration properties class, it actually allows people to also discover what configuration options are there, right? You can just do control space in your IntelliJ, and you get nice code assist on all of these configuration properties. So it also allows people to discover what configuration options there are and what default there are. And you can even include documentation by putting Javadoc on the fields inside of your configuration properties class. So that gives you some ideas. Another thing I wanted to mention is that sometimes it can even end up being beneficial to use auto configuration in a library that only has one client, right? It's not actually shared amongst many different services, but we still use auto configuration there. This is mostly for that encapsulation property that you get, right? It becomes completely self-sustained library where all I need to know as a client is, I put it on my class bot and I get this object that I can start to use. So things that we might configure in something like a client to connect to a third-party system, for example, is custom JSON marshalling requirements, right? They might have special needs in how you represent things like dates or how we handle null fields. Error handling is a common concern. If you make an HTTP request and a server responds with an error, that could contain JSON contents that we may need to parse and turn into an exception that we want to propagate. We may need to deal with things like authentication concerns. And actually, we have some really nice solutions for that, because what we very often do is when we have a custom error handler on the REST template and it finds out that it's getting something like a 401 because its token has expired or something like that, we just tell a token manager to refresh the token in the error handler. And then we throw a custom exception. And then what you can do is you can use a library called Spring Retry to say, oh, whenever this exception happens from my client that wraps a REST template, I'm just going to redo the call automatically. And you know that because the error handler will first trigger a refresh of the token before it throws the exception, that the next time this call will simply succeed because now you are working with a new token. And again, these are details that are important to get right, but you don't really want that to be in the face of everyone just using this library. They just should be concerned about the business operations being supported there. So that's the first thing I wanted to quickly mention, auto configuration. Next thing is observability. For messaging, especially. We are using a library which is called Spring Sleuth, and Spring Sleuth enables traces to be applied to your application. So it will automatically apply instrumentation to a lot of built-in stuff from Spring MVC, REST templates, other things, to create a trace ID whenever a request comes into the boundary of your system. And that will automatically get propagated to downstream services using a concept called spans. We use this for logging especially. And one of the things that we use in our platform is we use the SQS simple queuing service from Amazon. This is a point-to-point messaging solution. To integrate with that, we're using a community project which is called Spring Cloud AWS. Recently, actually, development of that thing has been picked up again. But we're using a slightly older version. It didn't have Sleuth integration yet, so we actually added it ourselves. This is fairly easy to do. So that means that whenever we put a message on a queue, it will be enriched with a header that has a trace ID and other information. And then when we pick it up again, that will automatically be used and will be part of logging, for example. This allows us to do two things. Basically, for the happy flows, whenever we send a message and we handle it, we can get all of the logging for that, even the asynchronous stuff, in a single trace. But more importantly, and that's what I want to get to, we can do this for managing messages that weren't able to be handled successfully. So first, the happy flow. You see an example here. What we do here is a request comes in for a player to reset their passwords. So this is ordered in time from top to bottom. Then that makes a request to the orchestration process service that says, oh, I first need to retrieve the account details. Then I'm going to actually request a password reset token. And then I'm going to put the message on the queue that we need to send an email to a player with their token. Now, for sending out emails, we use a dedicated marketing system that we connect to, and we have a service for that. But in this case, the marketing system tells us, yeah, that email address is actually blacklisted, so we've suppressed it. You cannot send an email to that. You can see that all of this logging actually appears together because I filtered here by a single trace, right? So that in itself is already super useful. But for this, you don't really need to do much unless you have to add your own Sleuth integration. If you're using something like RabbitMQ or JMS or Kafka, this stuff actually comes out of the box. What I wanted to quickly show you was something else, and that is what to do when a message fails to be delivered successfully, because what we have configured then is it goes to a dead letter queue. This is where messages end up that cannot be processed for whatever reason. The question is, when messages end up on a queue like that, what do you do with them? And the typical consultancy answer is, it depends. So what does it depend on? Well, it depends on what caused that message to not be processable. And I've actually seen people claiming that, oh yeah, if stuff moves to a dead letter queue, that's typically because of a bug in your system. That's actually not true. That is very rare occurrence that it's bugs that cause this. It could happen. In that case, you need to figure out what was wrong, and then maybe you can retry the message. But more often, it's caused by, for example, an external system not being available. You try to process a message. In order to do that, you have to call out to some third-party system. It's not there. So, well, you're going to throw an exception. Message ends up on a dead letter queue. In that case, it would be nice if we had a way to just retry that message. Right? Could also be that we couldn't process it because something in the world was actually in a different state than we expected it to be. Maybe we want to finalize some money reservation on the player's wallet, and the reservation is actually missing. Right? That's an inconsistency in state. We have different beliefs than what the systems that we connect with have. So again, then you need to do an analysis and then figure out what to do. What's also really important is that you are able to retry stuff in the first place, right? So always when you design these things as an architect, try to make message handling idempotent so that it's safe to actually process a message twice. Now, what we've done in order to help ourselves and our customer to handle these sorts of error conditions is we build a tool that they can use to see all of our dead letter queues. They can see how many messages are there. And then for every message, they can decide, okay, do I want to keep this thing? Do I want to maybe look at the related logging? Do I want to delete it? Or do I want to move it back to its original source queue so that it will be retried? And they can also do that in bulk for all messages on a dead letter queue. For example, if a system that wasn't available becomes available again. This is what it looks like. I'm sorry, I built this myself. I'm not a front-end designer in any way. So this is just using Timeleaf and a little Twitter bootstrap. But what you see here is that on this acceptance environment where I took the screenshot, we have two queues that have some dead lettered messages, right? I register loyalty points, so we cannot actually hand out some loyalty because in this case, the backend system doesn't know about our players. So it says, I don't know who you want to give these points to. And we have some problems with registering non-winning wagers. This is the queue that we use to say, hey, this ticket did not win anything, right? And if you want to run a successful lottery business, you're going to have a lot of tickets that did not win anything at the end of the draw. So let's imagine you click on that. You will be taken to this screen where we actually see individual messages. Now, I'm not actually showing any message contents here because we found typically it doesn't add any value. What we show instead is we show a link with a trace ID. So this is a Sleuth trace ID that will actually go directly to our central logging system, and then where you can see the related logging. And that is super useful because it will tell you why the message failed to be processed. Another thing we do is we have a little header here with a counter that shows how often has this message already been put back on a dead letter queue, because it might actually be retried and then go back. And for some queues, we actually do this stuff automatically. So because this is an acceptance environment, we're not really paying a lot of attention to it. This thing has been moved a couple of thousand times already, as you can see. If we click on a trace ID here, then what will happen is we will be taken to, in our case, Datadog, because that's the logging system that we use. And we can see all of the related logging now for this message. And this thing has been failing for a month already, so there's a lot of logging. So in this case, the messages are actually ordered from newest to oldest. And in this case, we can see that, again, it is related to something that couldn't be found in a backend system. But this tool has been super useful for the stuff that we do on a day-to-day basis. And I haven't really seen anything like that described or explained before. So we're doing this based on SQS, but of course, you could do something like this for other systems as well. Final thing I want to talk about quickly is our Spring Cloud Netflix usage. So this is the thing that started Spring Cloud in many respects. It's integrating the Netflix OSS stack, things like Eureka, Ribbon, Hystrix, and Zool. But a lot of that, with the exception of Eureka, actually became deprecated and is no longer being maintained by Netflix. And when that happened, Spring was also very quick to announce that they would eventually stop supporting it as well, though they had a very gracious period of you being able to move over. Now, we've only been using Ribbon for a short while in the beginning of our project, where we were also using some other stuff that we no longer need. So we actually switched to server-side load balancing already. So for us, Ribbon wasn't a problem, but we were actually also using Zool for proxy, and we were using Hystrix. And Zool we were using within our services. And I'm going to talk a little bit about Hystrix if I have time left, because I might actually skip that part. Looking at Zool, what we were doing is when the experience would talk to a process, sometimes the process needed to do actual work. Sometimes, however, it would just proxy through. So we wanted to have an automatic way of doing that proxying. That's what Zool did. To get rid of that, we simply said, okay, well, it's actually okay-ish. If the experience in that case knows, oh, for certain operations, I could just skip the process later and talk to the system, right? Breaks encapsulation a little bit, still is okay. It's also more performance. So we decided to just go with that. However, we have some other use cases for Zool where we're actually proxying to third parties, and we needed something for that. And what we're using there is Spring Cloud Gateway MVC. And this is not Spring Cloud Gateway, and most people I talk to have never heard about this thing. This is really just a little library that is a wrapper around a REST template. And I want to show you the code, and that's going to be the final thing we're going to talk about because then I'm out of time. What you see here is that we have an MVC method that takes a proxy exchange, and that's the thing that's being made available by the library. And then using that, what we can do is we can say, okay, we're going to copy over some headers. We're going to exclude something that we don't want to proxy. We're going to construct a new URL based on the incoming URL and some other stuff. And then that's your proxy, right? And it's like super simple. So that's something I wanted to quickly show you here as the third option. So to conclude, make sure that you know what your frameworks provides, right? Something like autoconfiguration isn't just for the framework itself. You can use it yourself to your own benefits. Make sure you understand the tooling and build tooling for the systems that you build, like custom dead letter queue handling as we had, and know what is there and also know what is still supported and make sure that you actually migrate to a supported solution in time. If you want to learn more, if you want to discuss some of the things I said or see them in more detail, please follow me to the Q&A because there we have some more time to dive into this. Thank you.
All right, what a great talk there. I love those use case talks, especially when it's about technology that I wrote. Please head over to the Q&A and continue discussion there and ask away, ask questions, and really discuss how that implementation was made possible. And up next, I have a really awesome presenter for you, one of my favorite people. So stick around for another great talk.